Okay, for Algebra 9.2 notes, we're moving on with parabolas and quadratic functions. We talked about this a little bit in 9.1, but the quadratic functions are usually written out y equals ax squared plus bx plus c. A is going to be your a term, the number that's in this position will be the b, and then obviously you have the c term. So we talked a little bit about the axis of symmetry, and I want you to take a look at these first three graphs. So the axis of symmetry is that line that like where you would fold over the parabola from one side to the other and it becomes symmetrical on both sides. So this is that dashed line. So in this problem, it's just slightly to the left of the origin. Okay, in the second parabola, it's a little bit more to the left. It's one whole unit away from the origin. And then in this one, it's 1.5 units to the left of the origin. So here's what you guys should know. The axis of symmetry changes with each change in the b value. So the b value in this first one is 2. This b value is 4, and see how it moved over a little bit more, and this b value is 6, so it moved over even a little bit more. And what I hope you're wondering is, why is it moving to the left, like toward negatives, when these are becoming greater and greater positives? So here's why. Some really smart mathematician came up with the ratio that relates the axis of symmetry and where it's placed in a b to a ratio. And then once they took it in the b to a ratio and they put like 2 over 2 and got 1, they were like, well, that's not quite right because it's actually at negative half. So just keep that in mind. And then they did the same thing here, 4 over 2. Well, that's just 2, but actually it's negative 1. So there was a little bit more to that. So what this mathematician did is they ended up coming up with the perfect equation for the axis of symmetry. And it is opposite b over 2a. So instead of having a positive 1, they made it a negative. And they also multiplied their a term on the bottom by 2. So this is a formula you guys absolutely need to have. I will write it on my whiteboard. In fact, I want you to write it out even though it's right there off to the side. And I want you to write the words axis of symmetry. So anytime you are looking on your parabola for where the axis of symmetry is, and in case you're wondering, that's always a vertical line that cuts your parabola exactly into 2 equal halves. And that axis of symmetry can be found by taking the opposite of b, and what I mean by opposite is if it was negative 2, it would be positive 2. If it was positive 2, it would be negative 2. So opposite b over 2 times your a term. Okay, that will find you the number that the axis of symmetry is on every time. So in our first example, if we would have solved opposite b over 2a, you would have got negative half. And that is why the axis of symmetry is on negative half right here. Okay, and then if we took opposite b over 2a, that'd be negative 4 over 2 times 2. That would have come out to be negative 1. Which is why the axis of symmetry is on negative 1 in this case. Okay, and then same thing here, opposite b over 2a, opposite 6 is negative 6, over 2 times a, which is 2. Negative 6 over 4 is the same thing as negative 1.5. So that is why it is negative 1.5. So that is the axis of symmetry. So you really need to make yourself familiar with opposite b, that looks like a 6. B, that's supposed to be a B. Opposite b over 2a. That is how to find the parabola's axis of symmetry every time. So if we were doing this problem, our a term is 1. Actually, it's always a good idea to write them off to the side. My a term is 1. My b term is negative 6. And my c term is 4. So if the first thing you want to do is find the axis of symmetry, don't cheat and look at what they have. We'll calculate it. You would do opposite b over 2a. So what that is opposite b is 6. Oh, so opposite of negative is a positive. So that should be positive 6 over 2 times my a term, which is 1. 6 over 2 times 1 is 2. 6 over 2 is 3. So the axis of symmetry is x equals 3. So again, what that would mean is if you were drawing out the parabola, the axis of symmetry would be over here at 1, 2, 3. It would be right here. Okay, and that's great and fine because we need to find where it is symmetrical on each side, but you still don't have a parabola. So let's take it one step further and find now where we can put some dots. Okay, so the next thing I want to teach you how to find is the vertex. So now that we know the axis of symmetry, you're going to find the vertex. And the vertex is half of our axis of symmetry. That 3 is going to be 3 comma something. And the reason we know it's 3 is because we know that the vertex is going to be somewhere on the axis of symmetry. So it's either going to be 3 and then something up here, or 3 and then something down here. So once you do your opposite b over 2a, that's half. That's not only the axis of symmetry, but it's also half of your vertex. So in order to find the other part, the other coordinate, to find where our axis of symmetry, where our vertex is at on the axis of symmetry, we have to plug in 3 for x. And the reason is because it is our x value and we're looking for our y. So we're going to take 3 and we're going to plug it in for x in this entire equation. So every time you see an x, I'm going to make it a 3. Okay, so let's write this out. So it's going to be 3 squared. I'm going to find some room somewhere. 3 squared minus 6 times 3 plus 4. Okay, and I'm just going to work it out. And that's what y equals. So that is what, in fact, if you want me to keep the y equals on it, that's totally fine. I can do that. So 3 squared is 9. 6 times 3 is 18, negative 18. That's why it's minus 18 plus 4. And you need to go left to right whenever you're doing adding and subtracting. So we've got 9 minus 18 plus 4. 9 minus 18 plus 4 is negative 5. So if y equals negative 5, that is my y coordinate for my vertex. So my vertex is 3, negative 5, and I know you probably cheated and saw that they already had that figured out here, but I wanted to show you how they figured it out. So 3, negative 5 means 1, 2, 3, negative 1, 2, 3, I didn't make my arrow long enough, 4, 5. So this is the vertex. You should already know that it's going to open up because it is a positive a term. If it was negative, it would open down, but since it's positive, it's going to open up. So here's my vertex. So I need to pick just 2 points because if I pick a point over here and another point over here, they will both reflect over the axis of symmetry, and that will give me all 5 of my points. But I'm going to show you one more shortcut. I'm going to show you how to find the y-intercept. So the y-intercept is obviously when x is at 0. So when x is at 0, I need to find where it's at on the y-axis. So let's think about it. If I made my x 0 and I plugged it in, that's going to become 0. That's going to become 0. And all it's going to leave is my c term. So the shortcut is whatever the c term is your y-intercept. So we've already got another dot put on there without doing any work. So here's my y-axis. 1, 2, 3, 4 is my y-intercept. And remember, it's going to reflect over because parabolas reflect. So if it was over here, whoops, my number there a little off. But I've actually already got 3 points on my parabola just by finding the vertex and knowing that the y-intercept is my c term. Okay, so I need to pick one more. Let's pick one of these 2 numbers because I want to see where my dot is going to be somewhere along the way. So I would either pick 1 or 2. And 1 tends to be a little bit easier to calculate, so I'm going to pick 1. So if I choose 1 for my x value, I need to work out this whole long problem again that I crossed out. Hopefully I can see that. to find where it hits on my y. So I'm going to plug a 1 in this time for x. So 1 squared minus 6 times 1 plus 4. So 1 squared minus 6 times 1 plus 4. All right, order of operations. Exponents first. 1 squared is 1. Multiply next. And then you can go left to right, add and subtract. 1 minus 6 plus 4. 1 minus 6 plus 4 is negative 1. So when x is 1, y is negative 1. So there's my dot, 1, negative 1, 1, negative 1, and it's going to reflect over the parabola to this side too, and now I've got my 5 points. Once you have 5 points on your parabola, you can stop graphing and call it good enough. And I'm just now noticing that we could have cheated and seen this entire parabola down here. Hey, it's good to know we did it right, right? All right, so now let's actually try one. Here's the you try. Step 1, we got to find that dashed axis of symmetry, and hopefully you have that memorized now. The axis of symmetry is opposite b over 2a. Let's write out. My a term is negative 1. My b term is 4. My c term is negative 2. So if I'm doing opposite b over 2a, I'm saying opposite 4, so is positive 4, so it's going to be negative 4 because that's the opposite, over 2 times a, which is negative 1. We're going to work that out. Negative 4 over 2 times negative 1 is negative 2. Negative 4 divided by negative 2 is positive 2. So my axis of symmetry is at 2. So my axis of symmetry is this dashed line that's going to be the spot where my parabola could fold over, and it's equal on this side as it is on that side. Okay? The next step is to know where on that axis of symmetry to put our vertex. And we know that half of it is 2. We just don't know what the number for the y-coordinate is after 2. So we need to find it. We know it's 2 comma something. So in order to find that, 2 is my x. I'm going to need to plug in 2 everywhere you see an x. This is a little tricky. That negative is not part of what gets squared. You need to do order of operations, square it first, and then that's like a negative hidden invisible 1 that gets multiplied back to it. So when we plug in our 2 here, it's just 2 times 2. And then the negative attaches itself to it because it's like being multiplied by a negative 1. So don't think that that 2 becomes a negative 2. It's not negative 2 squared. It's 2 squared times this negative 1. So what we've got is 2 squared plus 4 times 2 minus 2. And again, all I did was I took this equation and I'm plugging in 2 for all of my x's. Now we got to solve it. 2 times 2 is 4, times negative 1 is negative 4, plus 4 times 2 is 8, minus 2. Negative 4 plus 8 minus 2. Negative 4 plus 8 minus 2 is 2. So my y-coordinate is 2. So my vertex is 2, 2. So my vertex is 2, 2. All right, cool. Our parabola is 1/5 done because we've got 1 point. All right, shortcut. We know what the y-intercept is. The y-intercept is my c term. So let's go back up here and look at what my c was. C is negative 2. So on the y-axis, negative 2 is my y-intercept. So that is going to give us 2 dots because we know that the axis of symmetry is 2 away to the left. So I need to put my other dot 2 away to the right because it reflects over the axis of symmetry. I've got 3 dots. The only other one I'm going to try to put on is maybe one in between. So let's plug in a 1 for x. Let's see where my dot's going to be if I use a 1 for x. So I'm going to try a 1 now. So let's plug in a 1 for every time you see x. So negative 1 squared plus 4 times 1 minus 2. All right, 1 squared is 1, and then the negative attaches back to it. 4 times 1 is 4 minus 2. Negative 1 plus 4 minus 2. Negative 1 plus 4 minus 2 is 1. So 1, 1 is another dot. 1, 1. And guess what? It reflects over. Since it's a parabola, it is symmetrical. And now we've got our 5 points on our parabola. Very good. Okay, we should have known it was going to open down because it is a negative a term. So we knew it was going to open down. It's shifted because we've got a number here. It's away from the origin because we've got a number in our b term. So this is correct. All right, just for good practice, you can do the bottom, you try on your own, or I'm going to work it out too. I just think the more you do, the better you're going to get at this. So we've got 2 to try. Stay with me, or you can try it on your own and fast forward and see if you did it right. All right, I'm going to start with number 1. In fact, just try to not look at number 2 at all. So that's going to be hard to do. So the first thing you should do is opposite b over 2a. Opposite b over 2a. I'm going to write up here what my a, b, and c is. A is 1. B is negative 4. C is 1. Okay, so opposite b over 2a. Opposite b, our b was already negative 4, so it's going to become positive 4 over 2 times 1. So 4 over 2 times 1 is 2. 4 divided by 2 is 2. So our axis of symmetry is at 2. So our axis of symmetry is at 2. From there, we need to find where our vertex is somewhere on this. So we've got half of our vertex. We know that it's 2 comma something, but we got to go plug in 2 for x in this top equation. So I'm going to write out below that y equals not x squared, but 2. I'm going to plug in 2 for x. So 2 squared minus 4 times 2 plus 1. And then we're going to solve it. So 2 squared is 4. 4 times 2 is negative 8 plus 1. 4 minus 8 is negative 4 plus 1 is negative 3. Did I do that right? 4 minus 8 plus 1. 4 minus 8 plus 1. Yeah. All right, so negative 3. So our vertex is 2, negative 3. 2, negative 3. All right, out of our 5-point parabola, we've got 1 point done. Let's find 2 more. Let's go find the y-axis, or the y-intercept. That's easy because that is our c term. That's our c term. So it's 1. So on the y-axis, go up to 1 and put a dot. That's your y-intercept. It's 2 away from my axis of symmetry, so I can go 2 away the other direction and reflect it over. 3 points of our parabola. We only have 1 more to find, and you can either pick negative 1 and it's going to be somewhere up here and reflect it over, or we can go with positive 1 and find somewhere where it's in between. So usually positives are easier to calculate, so I'm going to choose 1. So I am going to choose 1, and I'm going to plug it in for x and see where it would be. So 1 squared minus 4 times 1 plus 1. All right, let's work that out. 1 squared is 1. 4 times 1 is 4. 1 minus 4 is negative 3. Plus 1 is negative 2. I think. I'm always, just use your calculator. 1 minus 4 plus 1. Negative 2. Okay, so 1, negative 2 is our last dot. 1, negative 2. The reason it's our last dot is because it reflects over. And now we have a 5-point parabola. All right, let's try our very last one. And I'm going to write it over here. Y equals negative 2x squared minus 8x minus 3. Ooh, I hope this fits on my graph. All right, so first thing you want to do is find that axis of symmetry by doing opposite b over 2a. My A term is negative 2, my B term is negative 8, and my C term is negative 3. Okay, so if we do opposite B over 2A, opposite of negative 8 is positive 8, over 2 times my A term is negative 2. Kind of ran out of room there. 8 divided by, that's going to be negative 4. 8 divided by negative 4 is negative 2. So my axis of symmetry is over here at negative 2. All right, I'm halfway to finding my vertex. I've got half of the answer. Actually, let me just write this like this. There we go. I need to find the other half by plugging negative 2 in to these x's and solving it. So it is negative 2 times negative 2 squared minus 8 times negative 2 minus 3. That's a lot to do. I hope you guys are using your calculator, not making silly mistakes. I hope I don't make a silly mistake. Negative 2 squared is positive 4. Positive 4 times negative 2 is negative 8. Negative 8 times negative 2 is positive 16 minus 3. So double check that that's right. I think it is. Negative 8 plus 16 minus 3. Oops, not negative 3. Minus 3 is 5. So negative 2 comma 5 is my vertex. Negative 2 up 1, 2, 3, 4, 5 is my vertex. All right, let's find the y-axis, the y-intercept. That is my C term. My C term is negative 3. So on the y-axis, go down to negative 1, 2, 3. And that is going to reflect over. So we're done with 3 out of 5 points. Let's find one more. I probably don't want to pick 1 on this time because I can see that 1 is going to be way off the graph. So instead, I'm going to pick negative 1 so that I can find somewhere where it's at in between here. I hope that makes sense. So I'm going to choose negative 1 next. And I'm going to have to plug in negative 1 to each of these x's. So hopefully I will not mess this math up either. So I'm going to do negative 2 times negative 1 squared minus 8 times negative 1 minus 3. Okay, oh my gosh, here we go. Negative 1 squared is positive 1 times negative 2, which is negative 2. Negative 8 times negative 1 is positive 8, and then minus 3. So negative 2 plus 8 minus 3. Negative 2 plus 8 minus 3 is positive 3. So 3 is my y for negative 1, 3. So we're going to go plot that. Negative 1 up 1, 2, 3. And I can reflect it over the line of symmetry, the axis of symmetry. And now we have all 5 points on our parabola.